Thank you for that introduction. We're really excited to be here at ODSC. Daliana and I are lucky enough to be in the same room in Seattle. So we're really excited to be sharing about the future of data science, how you can prepare for the future of data science. So without further ado, I think we'll be able to get into it. So super quick introduction. My name is Ali Miller. I work at AWS as the global head of ML for startups and venture capital. This is Daliana.
Hi everyone, I'm Daliana. I've been a data scientist for the past 7 years. I've worked on experimentation, machine learning, AI, and now working in supply chain.
Yeah, so we're really excited because we kind of wanted to do this fun co-presentation thing where we're able to cover machine learning from both the executive side, the practitioner side, combine those two together into one presentation to get you guys excited about the future of data science and machine learning. Not to scare you all with a scary stat, but that's what I'm going to do. We looked up on LinkedIn how many open machine learning roles there were a couple days ago, and there were almost 100,000 open roles. So if you're in machine learning now, note this hiring and skills gap. And if you're not yet in ML, know that there are 100,000 roles ready and crying and screaming for you. We're going to be talking about, out of those 100,000, obviously there are many, many different types of practitioners and data science builders. We're going to be focusing on the 5 main types. So I'm going to pass it to Daliana, who's going to kick us off. And then just kind of before we get into this, some expectations or rule setting, feel free to screenshot any single slide that you like. Feel free to tweet at us about something that you found interesting. We've got our Twitter handles throughout this presentation. So we really look forward to continuing the conversation after this presentation. But Daliana, kick us off.
Thanks, Ali. So if you have ever looked through a job board, you see roles like research scientist, applied scientist, machine learning engineer, and you might feel confused. So the responsibility of those roles really depends on the size of the companies or different type of organizations. And I always suggest people to focus on the skill set instead of the title. And today we're going to break down those skill set behind those roles one by one for you. And let's start with research scientists and applied scientists. So research scientists are focusing on developing innovative models, publishing papers. They usually have a master's degree or PhD degree, and they don't have to have a super strong software engineering skill, but they do need to know how to write code so they can prototype their their models. And then we have applied scientists. So applied scientists are basically research scientists plus software engineering skills. So if you interview for a company, you need to pass the SDE level 1 bar. And besides research, you also need to think about questions like, how do I put this model in production? How do I scale the solution? For example, what is going to be the latency of the model? So you're basically doing research and also thinking about machine learning operations. And now we have data engineer. Data engineers are software engineers focusing on data. So you don't need to do a lot of data analytics, A/B testing, or know a lot of statistics, but you do need to understand some fundamental statistical concept, like what is the distribution of the data, so you can detect some outliers. And you need to be very familiar with tools like Hadoop, Spark, and you do write a lot of SQL. But SQL is not all of it. Your job is to design high quality data schema, and you need to be able to tell what is good data, what is bad data. And how often do you need to refresh the data? You collaborate with software engineers and data science, machine learning engineers to understand their need for your data. And besides that, you also need to know GDPR or other security guidelines, HIPAA, data governance rules. So basically, you're the gatekeeper for not just good data, but also secure data for your company.
I'll take the other 2 roles. So data scientists, everyone is talking about data science right now. You get a master's degree in data science in about a year. There are part-time programs available to be able to do it in around 2 years, but data scientist is actually a really broad term. There are some that are a bit more focused on the product analytics side. You've got some that are a bit more heavy in machine learning, but kind of regardless of where you are in the spectrum, there's a lot of SQL, ETL, there's going to be a lot of BI reporting and A/B testing and kind of basic statistics. Regardless of where you are in that spectrum, the biggest thing that a data scientist is supposed to do is using data, provide some sort of insights to be able to make a decision so that you can determine, like, is my business good? Is my business healthy? And, you know, when we give a lot of talks on the education of AI, we always say, like, start with Excel, start with BI reporting, start with SQL, basic statistics, XGBoost, regression, other tree-based models. Start with these like foundational pieces, and then expand into things like data visualization, manipulation, libraries like NumPy or Pandas. But for a data scientist role, you do not need to pass the SDE 1 bar, SDE being software development engineer. You don't need to be a full-on coder, just helpful to kind of be able to use some of these libraries. Last one is machine learning engineer. You might also see it as MLE. Their biggest role is really to focus on the productionization of these ML models. And when we say productionization, we mean moving it out into the real world and focusing on things like hyperparameter optimization, algorithm improvements. It's less analytics and more around the actual system. So, you know, an MLE, their background is likely to be computer science. A lot of them are coming from software engineering, moving into that MLE role. And an MLE is focused on sort of the end of the data science cycle. Obviously, it's a full circle, but like it's focusing on that productionization side. You need to know designing the systems. You need to know MLOps, things like memory and latency that Daliana was talking about. But it's productionization. So those are the 5 main roles that we're going to be talking about. We get questions all the time like, I still don't get it. What's the difference between them? Here are some, brief ways of breaking it apart. So the difference between just a business analyst and a data scientist really comes down to that algorithm knowledge or that light coding knowledge, Python being, obviously the most important. But the difference between data scientist and MLE, machine learning engineer, is really that a data scientist really needs to know that BI and analytics work, whereas an MLE does not. And an MLE needs to be deeper in systems design and ML ops, whereas a data scientist does not. So I hope that helps a little bit. All right, data scientists and the entire world of data science, those 5 roles, crazy fast moving field. We want to be able to set you all up really well. You don't need to change everything that you're doing. So this talk is actually split into 2 pieces. The things that you are already doing and should totally continue doing, and then the things to start to incorporate into your workflow so that you're staying up to date. But I'll let Daliana start with things that are going to totally stay the same.
To be successful in data science, you need to be curious. And we know that you always need to be good at the data science fundamentals, know the basics, but that's not going to be enough. So you always need to be curious about what are the new tools out there, especially when you join a company. What is something only your company uses? And learning that is not a waste of the time. It helps you to have more ownership of the entire data science project cycle. And don't just learn the data science, machine learning models, learn the domain. Go to your org-wise, company-wise business meetings to see what is the business goals, because you can't develop a good model unless you know what you're optimizing for. And whenever you finish developing a model, don't just say, hey, I want to go out and celebrate. Ask questions. When something performs well, look into the data, the model, to see whether there's really some insights in the model, or maybe you just got lucky. What is the relationships among all those variables? And did you learn something new? Even if you fail, you can still leverage the data science pipeline you build for new projects in the future. And a lot of things gonna change, and you're always gonna be learning. And this sense of curiosity is essential. And everybody is spending a lot of time on Stack Overflow and Googling things. So it's okay if you find yourself doing that. Everybody is building the plane while flying it. And next, problem solving. So what are data scientists? We are essentially problem solvers. Think about Sherlock Holmes, except we have tens of thousands of pieces of information and we try to figure out the clues and solve the problem. And the most important thing is to know the current baseline, how the problem currently solved, because without knowing that, you won't be able to compare your new solution to the current solution. So then you won't be able to know how whether the problem is solved. And there are always going to be 1,000 things that you can improve. So it's important to know the baseline, know when it's good enough, when to stop. And the next important thing is you never solve the problem in a vacuum. There's always going to be constraints. You're not just doing a research with unlimited amount of time and resources. How much time do you need before you deliver the model? What is the budget? And you need to also work with software engineers, product managers, and talk to your stakeholders, because guess what? Things change. You want to make sure you're solving the right problems and collaborating with the right people.
Yeah, I had a manager that said, like, the first question you should always ask is, when is this due?
And who is going to use it?
You're on it. Yeah, exactly.
And next, of course, we're going to talk about data. Data is the field of decision making and machine learning. So when we look at the data, I always advise people, don't just dive into doing analysis or creating models. Try to ask questions. What are those columns mean? What do those empty value mean? Do they mean, are they zero, or maybe the database dropped something, or maybe this is not random, there's a story behind it. Try to understand the assumptions behind your data and challenge those assumptions. Talk to the people who give you the data. Sometimes you might even need to talk to your customers to understand what do this data mean. So it's also important to know what is good and bad data. Here is an example. So for example, you're trying to predict damage for a product in a manufacturing factory. And the environment is very dark, right? And maybe some images are very blurred. But for some data scientists, they want to collect more data. They downloaded some data from Google with very wide background, high resolution. From the surface, it looks like those are great data. Those are high quality data, right? However, those are actually bad data. Why? Because it doesn't match the actual environment where you're going to use the data to make a prediction. The data with very high resolution is not going to give you the right prediction when you actually implement the model in a dark manufacturing facility.
Keep in mind that, like, all these algorithm examples are real. I worked on a manufacturing facility example where people brought us, like, beautiful high-res images, and then in production, in environment, it just completely failed. And so that, despite it being high-res images, bad data. All right, thank you for covering the fuel. Now that fuel is used in models. So when it comes to models, there are new things coming out all the time. The most important thing, know the foundational algorithms, no statistics, no regression, specific models like random forest. But I always tell people, like, beyond the literal models, the more important thing to keep in mind is to know when to use them and why you are using each one. And it's about balancing the trade-offs for each one. The balance between precision and recall, the balance between variance and bias. You're having to bake in those decisions. You know, one example, like, you could be making a model that is the craziest, most accurate model, but it could take 10x the amount of money to build it. And so maybe that's a trade-off that you're not willing to make. You know, one example that we give all the time is like, let's say there are two models. One is trying to give a cancer diagnosis and help a doctor decide whether someone has cancer or not. The other one is email marketing and helping you segment a customer. Both of these can have the same false negative rate, but the risk of the false negative in the cancer example is so much higher than the risk of the false negative in the email marketing example. So your tolerance for risk and your tolerance for false negatives in one model or implementation might be wildly different. So always knowing why you're using each model and those trade-offs that you're making or implicitly making. And then outside of that, it's not just the model. Also keep in mind lightweight DevOps, lightweight software engineering skills, something like automating model updates, super important. Daliana and I talk about this all the time. Like communication, everyone always skips over it, but I cannot overestimate the importance of communication. It's about asking the right questions and getting those project requirements and goals up front. It's about asking collaborators what their goals are. This is actually my #1 tip to new hires whenever you're meeting people that you have to collaborate with. The first question you should ask is, I guess the first question is, what do you do here? But the second question is, what are your goals? And make sure those are aligned. And be able to justify your decisions to technical stakeholders, to non-technical stakeholders, maybe it's a head of sales. Be able to talk about, why did you pick Model A over Model B? What are the results of that? And it's kind of this iterative ability. Like, I'm sure you and I have both done this, but like, show things early. Pull aside one person, show that early. Yeah. Keep an open mind, always be listening, and be able to really create that iteration process so that you're staying up to date. All right, last one. Again, these are things you should totally be doing already, continue to do. Teamwork and community. Know who does what at the table, and both on your team and in the broader community. Maybe you're pairing with a software engineer to be able to move algorithms into production. Maybe you're partnering with product managers to understand specifications and goals like Daliana was talking about. Maybe you're going up to a leader and asking them like the right questions and asking what the overall impact of this project is hopefully going to be. And then one tip that I always give to folks is like, don't forget about your wider community. We have a text group of AI friends talking about the latest things. You can go to meetups in the park, maybe join a Discord channel, but always be tapping into the larger team and broader community as you're coming up to speed on data science and ML. All right, those are things that you're not going to be changing. You're going to keep doing, keeping that curiosity mindset, maintaining your problem-solving skills. But lots of things are going to change. I'm just going to kick us off.
So research is moving really fast. If you look at the NeurIPS 2020 report, there are almost 2,000 papers published in 1 year. So it's important for us to keep up to date to those trends and new researches. And if you feel you're overwhelmed, that's okay. Prioritize. Start with your own domain, start narrow. And once you feel comfortable about those new technology in your domain, and then you can expand. Leverage open source community. Use GitHub and Kaggle. Look at what is something new, some new models, new solutions. What are some open source notebooks that you can just grab some nugget and put it in your own pipeline. And the best way to learn is to do. So if you see there's some new model, you can just quickly test either it's a new tool or put a model in your own environment. And that's how you learn it, instead of just reading it and maybe you forget about it. And like Ellie mentioned, have a group of friends. So I have a few friends on the Slack group where we share new papers or news about AI, because just you can't follow all the news. You do this in a group, so you don't have to do everything on your own. And so as someone working in data, you're probably already partnering with software engineers and data engineers, but it's also important to think about who are not in the room, because data science is a team sport. You work with product managers, you work with sales, sometimes you even need to talk to legal. And when you want to develop your data for your customers, sometimes you need to talk to your end user, ask them how they're going to use it. And sometimes you need to go to the extra mile to talk to the domain experts. So Ellie, you build a machine learning model. Do you want to share your experience?
Yeah, we were working on a model for like dying trees and the ability to use satellite imagery and LiDAR data to, this is like a bird's eye view of trees to be able to figure out which trees are going to die. The example here is we worked with a literal like arborist, someone whose job is cutting down those dead trees. And we went on ride-alongs in his truck to really look at what these trees in real life look like, but partnering with that SME. And I love Daliana's example about football, but you want to share?
Yeah, so I worked on this football project where we tried to help this college football coach to find the best strategy for games. And I know nothing about football. So I actually bought a book to understand what are those terms in football. So when I sat down with a football coach to understand what features are important, I know what I'm talking about. And those has been very crucial, like how much time is left in the quarter, how many yards away from the end zone. So that helps me not just take the information from the football coach, but also take the information to think for myself, okay, what are some additional information I need to gather? And it doesn't matter how much data you have. If you don't understand your domain, you're not going to extract those critical information to develop a better model.
Totally. Also, this is the real book that Daliana bought, so shout out to Howie Long.
So next, governance. So security has always been important, but now it's not just the security engineers you sit next to responsibility, it's everyone working in data's responsibility. Because now as more companies has data science, machine learning teams, your model doesn't just sit in your local Jupyter notebook. It gets deployed in production and can impact a lot of people. So if you don't think about the security of your data, whether your model is biased, it's gonna have consequences. So when you think about your data, your model, think about privacy, right? For example, you have this very important feature that really helps you predict something, but maybe you shouldn't really use it. So whenever you use customer data, have the awareness and learn, GDPR, HIPAA is not just the security engineer's responsibility, it's your responsibility. And the danger of ignoring this might lead to legal issues.
All right, we got 3 more. So on tools, I already mentioned the skills gap. There are 100,000 or close to 100,000 open machine learning roles out there. And so when you think of tools, you should be thinking about, this is all around efficiency, how to make yourself more productive and the ability to scale yourself. You want to automate the repeated tasks or the really simple tasks so that you can take on the harder tasks or the more complex tasks. We like to break this into 3 sections: data, libraries, and engineering. On the data side, you want to be thinking about tools for ETL, data visualization, modeling, prod, even something like reporting and the ability to create really nice storytelling presentations. On libraries, you want to know your resources for open source. You want to be that Stack Overflow champ, but keep an eye out for new libraries or new trends that are happening. PyTorch has been really taking off in the research community. Hugging Face for natural language. These are new things you want to be tapping into. And then the last, engineering, particularly when it comes to folks that have roles that relate to ML ops, be thinking about what are the new tools out there that I should be tapping into. I work with global startups and we're working with Fiddler AI, Explainable AI, Tekton AI focuses on feature store and feature engineering, Synthesis AI, an incredible synthetic data generation startup. And synthetic data is going to be so important moving forward. So really making sure you're tapping into all these tools from Abacus to Fiddler. And then again, always really maintaining that sense of security and governance. All right, measurement. Before you even start, you should always be asking yourself, what is success? And that should be defined as a lot more than just what's my recall score, right? It needs to go deeper than that. It needs to tie back to product and business goals. You need to be able to factor in issues like algorithmic bias and data privacy. Like Daliana mentioned, you have to ask who's not in the room. You need to know your customer. One example that we talk about is like, let's say that I'm driving a car, but I share that car with 3 other people. Literally the biometrics of me holding the wheel and how I turn the wheel and how fast and what angle and how I press the pedal, just from the way I'm driving it, you can figure out that it's me driving it or the next person. And so questions around bias might be, okay, if I know that Allie is driving the car, should I recommend a different shopping experience for her? Is that going to have some implicit bias in it? So always asking yourself, what is the implication of the decision that I'm making? And then the last bit, this is a trend that we've really seen in the last 2 years since COVID, but it's, more AI professionals are baking in volatility into their analysis and using new efficacy measurements for model resiliency. So you need to make sure not to overfit your models during non-volatile times, or else during a volatile time, your model is going to be completely brittle. And so one thing that's become really popular and that there are now new tools coming out is really this idea of like scenario and what if analysis, the ability to say like, if everything keeps going, it'll look like this. If things go crazy, it'll look like this, kind of like a small, medium, large. But those measurements and those sorts of success impacts and how you're actually measuring that very different today than it was 2 years ago. All right, last one, AI. It's really big. PwC is saying that by 2030, it's going to be a $15 trillion GDP. So this is really important to tap into because as AI continues to grow, more companies and countries, probably both, are going to be adopting machine learning as a central part of their business rather than a side standalone sort of business. But it's going to become even more critical to efficiency, to scalability, to resiliency, which is what we just talked about. And so you want to be able to build those processes in place to manage multiple geos, multiple time zones. You're going to have to be thinking about remote collaboration and new, empathy for different cultures. But a lot of this is baked into the sorts of tools and processes that you'll be thinking about. And that goes to tiny nitty-gritty things like notebook sharing or availability zones and what you're tapping into, or as big as the way that 2 teams are talking to each other. But just know that, for the next 5 years, AI and ML is going to be even more central. All right, we are perfectly on time. We're going to be leaving this slide up as just a thank you. But, Daliana and I each have tons of followers in this space. We love sharing this. So follow both of us on Twitter, Instagram, LinkedIn, whatever. Some additional resources, definitely screenshot this slide. In terms of coding and building, Kaggle is super popular. Reading new research papers, arXiv is really popular to search, maybe a topic like federated learning. And then that very last one, breaking down ML topics. Towards Data Science, great blog. 2-Minute Papers is one of my favorite YouTube channels. And Amazon Machine Learning University has just been releasing all the classes that actually Amazon engineers take to learn things. So yeah, that's it. I think we'll be able to maybe take a question or two potentially. And so I don't know if the moderator wants to come off because for some reason I can't actually click the questions button. But maybe if we have like a question or two, we're happy to answer.
Yeah, I will send you privately the questions. Yeah, we got a question in your Q&A channel. There's a lot.
Feel free to just read it out loud because for whatever reason, we can't click on the drop downs.
Right. Okay. So the first question, will current data science roles disappear or change rapidly with GPT-3 and prompt engineering rapidly evolving? Is it still a safe bet to go for MLE or data scientist, let's say from now till the next 5 years?
I'm happy to take it.
Sure, you can.
Okay, so first, every single thing that we just talked about is that it is important to know how to learn. The entire world is going to look very different in 20 years. So more than saying like, I'm going to train for job X and that's going to be totally safe for the next 50 years, you should be thinking more around the types of skill sets that we were talking about. It's more around problem solving, it's more around curiosity. How do you stay up to date on research? How do you stay up to date on tools? That is primary in and out of machine learning. GPT-3, super exciting, opening up accessibility toward more builders. And even AWS is releasing a lot of new products that's really just widening what an ML builder can look like. And you saw that with web development, by the way. It used to be that you have to do raw coding in HTML, and then now, like, I just pop into Squarespace and make my own website. So we're seeing a very similar thing in ML, but even web developers now exist, and people thought that they were going to be on, 10 years ago. So I guess focus one is be a good learner, know your resources, find your community. And then part two is that widening of accessibility is really just to bring in more builders, not actually to kick out those that are already working on great things. Do you have anything to add to that?
Yeah, so I don't think, data science is going away just because everything is going to get automated. There are going to be more and more tools. I see them as data science empowerment. It will make our job easier, but you still need to understand the basic statistics, how to make decisions, to use those tools. So I think, like we mentioned, what's not going to change the fundamentals, your sense of curiosity. So really make sure you know the fundamentals, you know good programming language. The programming language might also change in the future, but they're all very similar. And be very good at the things that won't change, and also, keep an eye on what's changing and be able to adapt.
Yeah, there will always be the human component of communication, storytelling, decision making,
right.
Business impact. Maybe one more question. I can't remember if this goes another 10 minutes.
Yes, for the next one. Oh, you mean the second part of the question?
No, I think we can take the next question.
Another one.
Right, the next. What advice do you have for data scientists who plan on becoming entrepreneurs at some point in their career?
Yeah, maybe I can talk about to the entrepreneur, and you can talk about how they can what they can do once they start thinking about it. So I think it depends on what type of entrepreneur you want to be. I would just assume you want to be entrepreneur building some type of data science, AI applications or services. So I think it's very good to again learn the fundamentals and also accumulate a few years experiences in medium-sized or large company, not just be exposed to all the other talented people to learn from them, but also see how business is run in those environments, and then develop relationships while you're building your models. And then also the best part about it, while you're doing hands-on data science work, you realize nothing is perfect. It's difficult to get data. Sometimes it's difficult to train model. And those are all great opportunities. Those are problems for you to solve. So stay in the field and learn and really think about those challenges you face. And that can also be your future ideas when you want to build your own company to solve this problem. And Ali is the expert to give advice on when to have this idea to.
No, those are
okay.
That was perfect. I'm just going to add the examples that I actually mentioned in this talk. So there are tons of startups running on AWS that were founded by people who had been doing data science and machine learning, noticed a problem, went to create a company to solve it. Fiddler AI, founded by the guy who ran AI for the Facebook newsfeed, Krishna. Tecton AI, founded by the Uber Michelangelo team. They were all at Uber building this, and then they went to create a product around it. Abacus AI, founded by a former GM at AWS who is in machine learning. You've got, Scale AI, who they were working on machine learning products, and then only through working did they realize that there was a huge data labeling issue. So they created a data labeling company in somewhere around like 2013. It is now worth over $7 billion. These are startups that were launched by ML practitioners and ML builders that are now worth, unicorn status, and it all started with doing.
Great, thank you for answering that. We have the next question. As data science and AI get more popular, demand for talent will. What advice do you have for organizations that want to retain talent?
My advice for how to retain talent has is broader than ML. It's keeping people happy. It's asking them and understanding their goals. It's making sure that they feel supported for their best selves, right? That's like the actual retaining of talent. On the ML side, when we're talking about skills gap, there are a lot of levers that one can pull. One is the literal education and upskilling. Amazon Machine Learning University, the last thing that's on this slide that's up, is a really fantastic example of that, where AWS is actually providing training and certification courses for tons of companies. Or we have, you know, Deep Racer, which is a self-driving car little competition, where like Accenture has their entire racing league, but that's actually to like upskill Accenture and make sure that like there are more ML builders in-house. So one is the educational piece, and that could be allowing your employees to carve out time to learn new things. That could be funding educational courses. That could be bringing in educators from, you know, a Cloud Guru or AWS or whatever to come in and actually educate. Education's one. The second is really what we were just talking about with accessibility and broadening what it means to be an ML builder. It's not just like bare metal running every single thing on your own. It's tools like SageMaker, it's AI services like Personalize that are really opening up this whole space of what it means to be an AI ML builder, and the fact that like now things exist where you actually don't need any ML expertise to be able to build for that. So kind of a broadening of the stack, widening of accessibility, but also pillars and resources that allow for people in-house to actually upskill.
Yeah.
Have you seen any like upskilling tricks? Do you work on a wider team?
Like, right. I think for myself, for example, I learned machine learning through Machine Learning University within Amazon. Before that, I never trained any machine learning models. I think that definitely is helpful if you can provide your data scientist or machine learning engineer with different type of resources, support them to go out to different conferences. And also, although everybody's having like a similar title, machine learning engineer, data scientist, but people's interests are different. Some people like to talk to stakeholder more. Some people like to put their head down and write code. So I think it's very important not to just assume certain stereotype upon your employees, and then ask them what they feel passionate about and support that.
That's a great call out on conferences. This is a data science conference. The thing that is happening right now, ODSC, is a data science conference. So the ability to kind of say, hey, like, here's money, go fly to that conference, or, you know, register for free online, whatever that thing is. But I love the inclusion of conference.
Great, thank you for answering that. The next one question came up. What's a good way to switch into data science leadership positions from more traditional BI analytics leadership positions?
You literally did it, so.
Yeah, so I started my career as a business intelligence engineer, and I become a data scientist first. After a few years now, I just started to manage a team. I think it really depends on what company and what project you're working on. So for example, in your business, the BI part is very important. You have a big influence, and the data science is actually supporting maybe some reporting and business intelligence. Then I think you might not need to know everything, but you can read some papers, take some courses, or do some simple project, at least understand what is data science, and then you can start to include data scientists on your org, and then you can become a data science leader. But on the other side, if your company is very technical and the data science leadership role you're looking at requires really understand the model, understand even the engineering component like we talked about, then I suggest you to first transition to data science first, have some hands-on experience. And so then when you become a leader, you really know how to manage people, how to lead projects.
We got no additions. That was perfect. I think we got time for maybe one more question.
Yes, to make the last one. Hi there, how can I start myself starting to prepare for becoming a data scientist? What are the resources? From where should I begin?
Resources on, I feel, so Dalian and I post like every day new resources.
Yeah.
So I guess step one probably selfishly is follow Wes. As far as starting, do you have a favorite?
Yeah, I don't have a favorite. I think it's just, I don't know the background of this person who is asking the question. I would say if you're coming from a non-tech background, maybe you can start to think about some bootcamp. And before you apply to bootcamp, really talk to your data science friends and just search on YouTube, what do data scientists do, to make sure that's something you want to do. Because data science work is not, as glory as what you imagine. So I think step one is really understand what a data scientist do, and then maybe apply for a master's degree, a boot camp, and there are also a lot of free online resources. I think if you can learn a subject while doing a project, that's the best way for you to learn. And also, if eventually you want to find a job in the industry, you can search what questions they ask, so you can get prepared early while you're learning the actual skills. And if you're already studying, statistics or some related engineering or area, it's easier for you to transition. Again, look up the roles we just talked about: research scientist, applied scientist, data scientist, data engineer, machine learning engineer, to see what is required in those roles, and then try to learn a skill that help you bridge the gap.
I always like Ken G, who's another presenter during ODSC this year. He's another great one to follow. He gave an example where he started with like collecting data on himself to run a project, which I really liked. All of the resources that are on the screen right now are the places to start, but maybe you're tracking like how happy you are every day and what exercise you're doing every day. And so you're able to kind of like make a little model about your own life. I think that's one kind of fun example, like find data on yourself. The second, which is just for my own life, is like pick something that actually excites you. When I was in college, that's when I started doing ML research, but my focus was natural language. I did not take on the entire world of AI and machine learning. I started with something really, really niche, and I started with sentiment analysis, natural language, and classification, and then I expanded into computer vision, whatever. But starting with something that interests you, because you want to fuel that passion for learning, as Donna said, like it's not all as sexy as it's cracked up to be. And so you want to like pick the thing that actually excites you and not some boring math problem that you're not that